Hi everyone, we're going to solve this differential equation. This is a differential equation because there is a derivative in this equation. And we're going to look for the particular solution given that b of 0 equals 20. Since we're looking for the particular solution, we're going to use the acronym of SYS to help us solve this. The first S stands for separate. So let's separate this equation. Let's get the b's on the left and the dt on the right. So we can divide over this 100 minus b. So we'll divide it over and we'll multiply the dt over to the right. So we separated. Next step will be to integrate. So we're going to integrate each side. When we integrate the left, since this 100 minus b is in the denominator, it's a natural log of the absolute value of 100 minus b. The b in there is negative, so we get a negative. And if you weren't sure about that, you could use u substitution. If you allowed u to equal 100 minus b, then du would equal negative 1 db. Notice we do not need any negative here. It's only 100 minus b, so we'll divide the negative over to the left. So that negative du equals db. Now we can write the whole integral in terms of u. And when we integrate, u to the negative 1, we get negative ln of u plus c, where u is the 100 minus b. And on the right, we have 150 t, so this becomes 150 t, and we'll write the plus c. Okay. Okay, so after we integrate, we're now going to look at this next S. We're going to solve for C. So I'm going to circle the equation, the one where we just first integrated, and right now, before we do anything else, we will solve for C. So I'll plug in for B, we have 20, and for T, it's 0. Negative ln of 80 equals C. We now have our C. Now we will go ahead and isolate, right? This I here stands for isolate. We'll go back to the equation we just circled when we first integrated, and we will replace the C with negative ln of 80. So negative ln 100 minus B equals 1/5 t minus ln of 80. Now let's isolate b. So there's a negative in the way. Let's divide everything by negative 1. ln of 100 minus b equals negative 1/5 t plus ln of 80. Our b is stuck inside of a log. So to get it out, we'll use the inverse operation of exponents. So my base is e raised to the 1/5 t plus ln of 80 equals the absolute value of 100 minus b. To get rid of the absolute value, we know that inside absolute value could be a plus or minus value. So we have plus or minus e to the negative 1/5 t plus ln of 80 equals 100 minus b. All right, so before we get b by itself, we could work on this last S and select our choice. Is it plus or is it minus this E expression? So remember, the 100 minus B is what was inside the absolute value. So that value is either a plus or a minus. And we can use the given point to us. We see that the output of Y, or B in this case, is a positive value. So therefore, what was inside this absolute value is a positive E to the negative 1/5 T plus ln of 80 equals 100 minus B. Now I will add the B to the left and subtract the E over to the right. All right, I'll add B and subtract this whole expression to get B equals 100 minus E to the negative 1/5 T plus ln of 80. Now, free response, you can leave it like that. But chances are, if this is multiple choice, it won't look like that. So let's look at this expression here with the E. Remember, this E, well, let's just write it first. B equals, we'll simplify it. B equals 100 minus E and ln are inverse operations, so they undo each other. So this could just be 80 E to the negative 1/5 T. And this goes by the rule, and I'll just write it like this for now. If I just have E to the T plus ln of 80, when do we add exponents? When we multiply bases. And since E and ln undo each other, and that is because E to the ln of 80, if I write question mark here, if I convert this to a log, that would be ln, my base is E, question mark equals my exponent. Well, that's why the question mark is just 80. So this is why we're allowed to do that. Going back to this part right here. Suppose you didn't decide yet about the plus or minus. We can use this condition once again. Once again, let's make sense of this. We know when our input is 0, our output is 20. In other words, B is 20 when T is 0. Well, when would that happen? If I have 100 minus 80E, if T is 0, oh, I get 100 minus E to the 0 is 1. So 20 equals 20, check. So you can use this point to determine the plus or minus by solving out the final answer, or while it's still in when you first take it out of the absolute value, just considering the fact that this is positive, we chose the positive value here. So therefore, this is our final answer. Here's our next differential equation. And again, we're looking for the particular solution, so we'll use cis. And first, we will separate. So to separate this, one way to look at this equation, on this right-hand side, we can look at this as y minus 1 times 1 over x squared. So that when we separate it, we can divide the y minus 1 to the left, giving us dy over y minus 1 equals 1 over x squared dx. So now they are separated. Now we can go ahead and integrate. And so on the left, I have y minus 1 in the denominator. So this is just ln of y minus 1. I don't need a negative on the outside because my y is positive. If I use u substitution, derivative of y minus 1 would just be 1, so it's good. Equals 1 over x squared. I can look at this as x to the negative 2. So I need to add 1, so we get x to the negative 1 over negative 1 plus c. But that doesn't look nice. Let's rewrite that. So I'm just rewriting the left. And this is just negative 1 over x plus c. All right, we just integrated, so I will circle this equation because now we will go ahead and solve for c given this condition. So there's ln of 0 minus 1 equals negative 1 over 2 plus c. ln of 0 minus 1 is ln of 1, which we know is just 0. How do we know that? If I put a ln of 1 equals 0, remember my base is e to what value gives me 1? Well, anything to the 0 power gives me 1. So we know that this left-hand side just equals 0. Therefore, 1/2 equals c. Next step is to now isolate. Our next isolate. So we go back to our circled equation right after we integrated, made it look nicer. So ln of y minus 1 equals negative 1 over x plus 1/2. Let's get y all by itself. Y is stuck in a log, so write it in exponential form. Equals absolute value of y minus 1. And now, to get it out of the absolute value, it's plus or minus e to the negative 1 over x plus 1/2 equals y minus 1. Now this one's a little tricky because I just took this out of the absolute value. Can I make a decision now? Normally I would go back to this point and look at the y value and see if it's positive or negative, but in this case, my y is 0. So, I'm not really sure what I need to pick just yet. All right, well, since I'm not sure, let's get y by itself. So I'm going to add the 1 over to the left. I'm sorry, I'm going to, add the 1 over to the left. So I get y equals, so I'm adding this 1 over. So it's 1 and plus or minus e to the negative 1 over x plus 1/2. And now I have this condition of 2 comma 0. So what's going to make this statement true? Let's see, if I plug in 2 for y equals 1 plus or minus e, when I plug in, oops, made a mistake here. This is 0 for y, sorry, 0 for y, e to the negative 1 over 2 plus 1 over 2. Well, 1 plus or minus negative 1/2 plus 1/2 is e to the 0. E to the 0, e to the 0 is just 1. So I know 1 minus 1 is what will give me 0. So I'm not going to use that positive there. So final answer, I'll write it over here, final answer, which will satisfy my condition of 2 comma 0 is y equals 1 minus e to the negative 1 over x plus 1/2. Final answer. So these could be tricky. Again, if my y value is a positive or a negative, you can make that decision right here in this step when you first remove the inside value from the absolute value. If not, you can always isolate and then plug in that point to see which one works, which one satisfies this condition. I hope this was helpful.